According to the statistical data, fuel cell vehicles run on clean and burning hydrogen and are 3 times more efficient than combustible engines. Good morning, sir. This is Bhavya Jha of Computer Science and Engineering Department from first year, and today my topic for the presentation is construction and working of hydrogen oxygen and methanol oxygen fuel cell. Moving on to the next slide. Here we have the outline of the entire presentation. Introduction to fuel cells, basics of fuel cells, hydrogen-oxygen fuel cell, hydrogen-oxygen fuel cells components, the working principle, their advantages, challenges and considerations, methanol-oxygen fuel cell, its components, and finally, comparison and future outlook of both. In this slide, we have introduction to fuel cells. It's a brief overview of sustainable energy solutions. Fuel cells are devices that convert chemical energy directly into electricity without combustion. They offer a clean and efficient energy solution. It provides electricity and water when combined with oxygen. They are eco-friendly with no emission of greenhouse gases. They have many diverse applications in transportation, stationary power generation, etc. This slide is about the basics of fuel cells. Fuel cells are the electrochemical devices that generate electricity by converting the chemical energy of a fuel directly into electrical energy without combustion. They consist of anode, cathode, and an electrolyte in general. Talking about anode, this is where the fuel is oxidized, hence releasing electrons. Cathode is where oxygen reacts with electrons and sometimes another reactant to form water or other byproducts. And electrolyte is a substance that separates the anode from the cathode. It is also a substance that conducts ions between the anode and the cathode. Coming over to hydrogen-oxygen fuel cell in general, these cells are very fascinating because they are energy converters that produce electricity through electrochemical reaction between hydrogen and oxygen. One of the biggest advantages of hydrogen-oxygen fuel cell is that they produce electricity without combustion. They can convert a higher percentage of the energy content in hydrogen into electrical energy. Typically, they have an efficiency of 40 to 60%, whereas the conventional or the traditional methods of combustion only have an efficiency of 20 to 30%. Now let's talk about the fuel cell components. In general, there are 5 most important components as mentioned in the slide: anode, cathode, electrolyte, catalyst, and external circuit. Now, according to the given diagram, anode is where hydrogen is introduced. Cathode is where oxygen is introduced. These both constitute the electrodes. Then we have electrolyte, which is in general alkali potassium hydroxide. As mentioned above, electrolyte separates anode and cathode and helps in the transfer of ions between them. Finally, we have a catalyst. This catalyst is very important in hydrogen-oxygen fuel cell as it increases the chance of electrochemical reaction taking place. Then finally, we have the external circuit, which completes the entire hydrogen-oxygen fuel cell. This external circuit also helps in the flow of electric current, thus completing the entire hydrogen-oxygen fuel cell. Working principle of hydrogen-oxygen fuel cell. Electrochemical reaction. At the anode, hydrogen molecules split into protons and electrons with the help of a catalyst. That is, 2 hydrogen molecules gives way to 4 H plus ions plus 4 electrons. Then we have the electrolyte separation. A membrane electrolyte allows only protons to pass through to the cathode, blocking electrons. Then we have external circuit, and finally we have the cathodic reaction. At the cathode, oxygen combines with protons that travels through the electrolyte and electrons from the external circuit to form water and heat. That is, oxygen combines with 4 H plus ions and 4 electrons to give 2 molecules of water. Thus, we have the energy generation. The flow of electrons through the external circuit generates electrical power, with water being the only byproduct as hydrogen and oxygen combine. Thus, 2 molecules of hydrogen combine with 1 molecule of oxygen to give 2 molecules of water. And this is how hydrogen-oxygen fuel cell actually works. Given is a diagram through which we can observe how the hydrogen-oxygen fuel cell actually works in general. Now let's talk about the advantages of hydrogen fuel cells. As stated above, fuel cells are much more efficient compared to the conventional combustion cells. Therefore, the advantages of hydrogen fuel cell are so dynamic. The very first one is clean energy production. Then we have high efficiency and versatility in applications. The challenges and considerations are that hydrogen oxygen fuel cell till date remains costly because hydrogen is an expensive fuel. The infrastructure. Developing a comprehensive infrastructure for hydrogen production, storage and distribution is crucial. But it also requires a minimum cost to be available. Hydrogen production. Most hydrogen is currently produced through methods like steam reforming of natural gas or electrolysis, which often rely on fossil fuels or electricity from non-renewable sources. Finally, let's talk about the methanol oxygen fuel cell. Now, the fuel that is used in methanol oxygen fuel cell is a methanol, which is a liquid at room temperature. The operation is, in these fuel cells, methanol is oxidized at the anode to generate protons, electrons, and carbon dioxide. Methanol oxygen fuel cells can achieve high energy conversion efficiency. As shown in the given diagram, this is the entire working of methanol oxygen fuel cells. That is, from the anode, we introduced methanol. From the cathode, we introduce oxygen. Then there's an electrolyte separation between the two. There's an electron flow. And finally, the entire methanol oxygen fuel cell gets complete. Methanol fuel cell and its component. Just like hydrogen oxygen fuel cell, methanol oxygen fuel cell also has 5 very important components. That is anode, cathode, electrolyte, catalyst and external circuit. And a brief description about them is given in this slide. Now let's compare and look for the future outlook between hydrogen oxygen and methanol oxygen fuel cell. Now, in terms of fuel source, hydrogen oxygen fuel cell uses hydrogen gas as the main fuel source, requiring a separate infrastructure for hydrogen production, storage, and distribution. On the other hand, methanol oxygen fuel cell utilizes methanol, a liquid fuel, which is easier to transport and store compared to gaseous hydrogen. Now, let's talk in terms of efficiency. Hydrogen oxygen fuel cells have high efficiency in converting the chemical energy, and methanol oxygen fuel cell offers slightly lower efficiency as compared to hydrogen oxygen fuel cell. So this was a complete outlook about hydrogen oxygen fuel cell and methanol oxygen fuel cell. We understood about their efficiency, about why they are used, how they can be used as a clean and more generative source of fuel as compared to the conventional sources. And with this, I end my presentation. Thank you. Presentation by Bhavya Jha from Computer Science and Engineering Department, first year. Thank you.